Hello there, gentle souls. Welcome to Conscious Frequency. Here, we explore the profound mysteries of existence, weaving together the whispers of science and the echoes of philosophy. Settle into a space of gentle curiosity, where wonder is our guide. Today, we embark on a journey through the slow turning of timeless physics. We'll drift through concepts that shape our understanding of reality, from the quantum dance of subatomic particles to the vast, silent ballad of cosmic evolution. This isn't about memorizing formulas, but about feeling the deep resonance of universal laws, allowing them to shape our perception, and perhaps to guide us towards a deeper sense of peace. As you settle in, perhaps with a warm drink or a cozy blanket, tell us in the comments below, where are you listening from today? What small, quiet moment of beauty have you noticed in your world recently? Your presence here enriches our shared exploration. If the gentle currents of thought and discovery resonate with you, consider subscribing to Conscious Frequency. Each new video is an invitation to a deeper dive, a shared breath in the vast ocean of knowledge. Hit that notification bell so you don't miss any of our unfolding explorations. Over the next 2.5 hours, we will explore 25 chapters, each a stepping stone in understanding the subtle, yet powerful, forces that govern our universe. Allow your breath to deepen, your thoughts to soften. Let this be a space for quiet contemplation, for the slow, beautiful turning of your own awareness. Our journey begins at the very edge of existence, where reality itself seems to shimmer and hum with an unseen energy. And as we venture deeper, past the familiar, into the realm of the infinitesimally small, we find ourselves in a place that defies our everyday logic, a place where the very fabric what we call real is woven from possibility rather than certainty. This is the quantum realm, the unseen substrate beneath all that we experience. Here, particles aren't quite solid things, but rather tendrils of probability, existing in a kind of hazy, undecided state until something, or someone, nudges them into a definite form. Imagine a mist, swirling with potential rain, but not yet a single drop. That's the essence of it, a world where what could be is as real, perhaps even more real, than what is. It's a delicate dance of probabilities, a constant whisper of potential. And in this quantum ballet, we encounter a most peculiar phenomenon, a wave-particle duality. It's as if the universe can't quite make up its mind. An electron, for instance, can behave like a tiny, discrete ball of matter, a particle you could, in theory, hold, but then, it can also spread out, like a gentle ripple across a vast, silent lake, a wave of pure energy influencing everything it touches. This duality isn't a contradiction, but rather a hint at a deeper, unified nature underlying what appear to be such starkly different behaviors. It's like discovering that the same water can be a solid ice crystal, a flowing river, or an invisible vapor, all at once, depending on how you look at it, or rather, how you interact with it. This leads us to one of the most profound and, frankly, mind-bending aspects of the quantum world, the Bose observer effect. It turns out that the act of looking, of measuring, of interacting with these tiny entities actually changes them. The universe, at its core, isn't just a passive backdrop for our lives, it's an active participant, subtly shaped by our very presence, by our curiosity. It's as if the mist of potential rain only decides to become a drop when you hold out your hand, anticipating it. This suggests a profound interconnectedness, a delicate dialogue between the observer and the observed that's happening all the time, even when we're not consciously aware of it. And then there's quantum entanglement, a concept so strange it even made Einstein scratch his head. Imagine two particles born from the same event, becoming intrinsically linked, like two perfectly synchronized dancers. What happens to one instantly affects the other, no matter how far apart they are, across a room, across a galaxy, across the universe. There's no signal sent, no delay. It's a spooky action at a distance, as he called it, suggesting a deeper, non-local reality, a cosmic thread binding seemingly separate points into an inseparable whole. Imagine two perfectly synchronized dancers, moving as one even when separated by an immense stage. Their connection is not through signals, but through an inherent, timeless bond. This is the essence of entanglement, a silent, instantaneous conversation across the void. But how does this ephemeral quantum realm, this world of mist and whispers, give rise to the solid, predictable world we perceive every moment? What bridges this astonishing gap between the probabilistic and the concrete? From the impossibly small, let us expand our gaze to the grand tapestry upon which all existence is woven. Now, here's the beautiful part. We've been talking about the tiny, the quantum dance. But what about the stage itself? What is this vast, invisible theater where all of reality plays out? For so long, we imagined space as a kind of empty box, and time as a steady, ticking clock, indifferent to everything happening within. But then came Einstein, a mind that saw the universe not as a static painting, but as a living, breathing sculpture. He gifted us the idea of space-time, not as a backdrop, but as a unified, dynamic fabric. And gravity, that force that pulls us to the Earth, that keeps the planets in their orbits, isn't a mysterious tugging at a distance. No, gravity is simply the curvature of this very fabric. Imagine, if you will, a vast, perfectly smooth rubber sheet stretched taut and still. Now, place a heavy bowling ball right in the center. What happens? The sheet dips, it warps, it creates a gentle indentation. That indentation, that curve in the fabric, is precisely what Einstein described. Mass and energy, anything that has substance, warps the spacetime around it. It's like placing a heavy object on that stretched sheet. And this warping, this subtle bending, is what dictates the paths of everything else. A marble rolled across the sheet, instead of going in a straight line, will curve towards the bowling ball, following the dip. That's how planets orbit stars, how light itself bends around massive galaxies. It's not a pull, it's a following of the curves. And the most astonishing thing, this bending doesn't just affect space, it affects time too. Time, that constant companion, isn't as absolute as we once believed. In stronger gravitational fields, where space-time is more deeply curved, time actually slows down. Think of it like this: the deeper you go into that indentation on the rubber sheet, the more the fabric is stretched, and the slower things move. So, time passes a fraction of a second slower for you if you're standing on the surface of the Earth, compared to someone floating far out in space. It's a subtle difference, yes, but it means time is relative, a personal journey shaped by your position within the grand cosmic weave. But the fabric of space-time isn't just passively curved, it can also ripple. Imagine those massive cosmic events we've touched upon, two black holes, cosmic titans, spiraling into each other, merging in a cataclysmic embrace. When such monumental events occur, they send out ripples through the very fabric of space-time, like a stone dropped into a perfectly still pond. These are gravitational waves, a cosmic hum, a whisper from the universe's most violent moments. They travel at the speed of light, carrying with them the echoes of ancient collisions, the stories of celestial giants dancing their final, magnificent waltz. Think of space-time as a vast, silent ocean. Massive objects are like submerged anchors, creating gentle depressions in the water's surface. When two anchors collide, they send out waves that travel outwards, carrying the story of their interaction. If space-time itself can bend and ripple, what does this imply about the ultimate structure of the cosmos? From the pliable fabric of space-time, let us listen to the grand composition it orchestrates across the eons. You know, when we look out at the night sky, it's easy to imagine ourselves as static observers, peering into a vast, unchanging void. But the universe, my friends, is anything but still. It's a symphony in motion, a grand, unfolding performance. And the most profound revelation is that the universe isn't just expanding us into something. It's the very space itself that's stretching, like an invisible, cosmic balloon inflating. Imagine galaxies, these luminous islands of stars, not rushing away from each other through empty space, but rather being carried along, gently nudged apart as the very fabric of their existence grows. It's a subtle, yet mind-bending distinction. And how do we know this cosmic dance is happening? Well, scientists have a clever way of listening in. They look at the light that travels to us from these distant galaxies. As the space between us and them expands, that light gets stretched, too. Think of it like a siren's song, its pitch lowering as the source moves away. This stretching of light shifts it towards the red end of the spectrum, a phenomenon we call redshift. And the further away a galaxy is, the more its light is redshifted, meaning it's moving away from us faster. This beautiful relationship, this cosmic speedometer, is known as Hubble's law. It's a testament to the universe's ongoing expansion, a quiet hum that tells us about its past and its future. But there's another, even more ancient whisper we can detect. It's called the cosmic microwave background, or CMB. Imagine the universe as a newborn, incredibly hot and dense. As it expanded and cooled, it left behind a faint, pervasive glow, a sort of thermal afterglow from that primordial moment. The CMB is like a snapshot of the universe when it was just a toddler, a mere 380,000 years old. It's a whisper from its infancy, filling every corner of space with a gentle warmth, a constant reminder of where it all began. It's the universe's first lullaby, still echoing softly. And as we listen closer, we start to notice patterns in this grand composition. Galaxies aren't scattered randomly like dust motes. Instead, they clump together, forming vast, intricate structures. Imagine cosmic rivers of stars flowing through immense, empty voids. These are the cosmic webs, the filaments, the clusters, and the superclusters. They're shaped by gravity, that unseen sculptor, working patiently over billions of years, drawing matter together, creating this breathtaking, three-dimensional tapestry that stretches across unimaginable distances. It's a testament to the subtle, yet powerful forces that govern our universe. It's a bit like baking a loaf of raisin bread. You mix the raisins into the dough, and as the dough rises in the warm oven, the raisins themselves don't move through the dough. Instead, the dough expands, and the raisins are carried along, moving further apart from each other. The dough is our space-time, and the raisins are the galaxies, all being gently nudged apart by the universe's own expansion. But what invisible forces are shaping these cosmic structures, guiding the dance of galaxies? The visible universe, though magnificent, is only a fraction of the cosmic story. Much of it remains shrouded in a profound mystery. Take your time with this thought. We've been gazing at the stars, at the luminous dance of galaxies, and it's easy to feel like we're seeing the whole picture. But what if I told you that all the starlight, all the nebulae, all the swirling cosmic dust we can ever hope to capture with our most powerful telescopes, it's just the tip of a vast, invisible iceberg? This is where we meet dark matter. It's this elusive substance that doesn't reflect, absorb, or emit light, making it utterly invisible to our eyes and our instruments. Yet, its presence is undeniable, a silent conductor orchestrating the grand ballad of the cosmos. We know it's there because of its gravitational pull, a subtle but insistent tug that shapes the very fabric of space. Think about it: galaxies, these immense islands of stars, they spin, and the stars on the outer edges, they're moving so much faster than they should be, based on the gravity of all the visible matter we can see. It's like a merry-go-round spinning so fast that the horses on the outside should be flung off into the night. But they're not. They're held in place, tracing their orbits with a steady grace. This anomaly, this galactic rotation anomaly, points to a vast halo of unseen mass, this dark matter, providing the extra gravitational grip to keep everything together. It's as if the galaxies are wearing invisible, gravitational cloaks. And then there's the way light itself behaves. When light from a distant galaxy travels across the universe, it doesn't always travel in a perfectly straight line. It can be bent, deflected by the gravitational influence of massive objects in its path. This phenomenon, called gravitational lensing, acts like a cosmic magnifying glass, and sometimes a cosmic funhouse mirror. By observing how the light from these distant objects is distorted, we can actually map the distribution of dark matter. It's like seeing the ripples on a pond created by a stone you can't quite see. The bending of light tells us where the unseen mass is concentrated, revealing the invisible architecture of the universe. So, dark matter isn't just some abstract concept, it's the unseen scaffold, the invisible framework upon which everything we see is built. It's the gravitational architect of the cosmic web, the vast, interconnected structure of galaxies and clusters that stretches across the universe. Without this dark matter, the galaxies we admire, the clusters we study, they simply wouldn't have formed in the way they have. It's the silent, unseen hand that gathered the gas, that pulled the matter together, allowing the stars to ignite and the galaxies to bloom into existence. It's the foundational blueprint, written in the language of gravity. Imagine a vast, invisible net spread across the cosmos. Galaxies are like dewdrops clinging to the threads of this net, their positions and movements dictated by the unseen structure holding them. It's a delicate, yet powerful, web of influence. But if gravity is the sculptor, what is the force that seems to be pushing the universe apart at an accelerating pace? As our understanding of the universe deepens, we encounter an even more enigmatic force, an invisible hand pushing everything further apart. And so, we find ourselves at a rather astonishing crossroads in our cosmic journey. We've spoken of the grand tapestry of existence, the intricate dance of matter and energy, and the gentle hum of the cosmos. But what if I told you there's a force, a phantom limb of the universe, that's not just holding things together, but actively pushing them away, and doing so with increasing vigor? This is the realm of dark energy, a term that sounds like it belongs in a forgotten alchemist's laboratory, but it's very much a cornerstone of modern cosmology. It's this subtle, pervasive presence that's responsible for the era's accelerated expansion of the universe. Imagine the universe as a vast, dark ocean, and we thought the currents were slowing down, perhaps settling into a gentle drift. But no, the tide is actually gathering strength, pulling galaxies further and further apart with an unseen, relentless momentum. The true nature of dark energy remains one of the most profound puzzles we've ever faced, like trying to grasp smoke or understand the silence between notes. How did we even stumble upon this cosmic secret? Well, it was through the delicate artistry of observation, specifically by looking at Type A supernovae. Think of these as cosmic lighthouses, incredibly bright stellar explosions that, because of their consistent peak brightness, act as standard candles. By measuring how faint these distant lighthouses appear, astronomers can gauge their distance. And by observing the red shift of their light, how much it's been stretched towards the red end of the spectrum, due to the expansion of space, they can determine how fast they're moving away from us. What they expected was to see the expansion slowing down, a cosmic deceleration as gravity, the great cosmic sculptor, pulled everything back together. But the data painted a startlingly different picture. The supernovae were fainter than expected, meaning they were further away than they should be if the expansion were slowing. This could only mean one thing: the universe's expansion isn't just continuing, it's speeding up. It's like finding out your car, which you thought was coasting downhill, is actually accelerating on its own. Now, this idea of an accelerating universe might bring to mind something Albert Einstein pondered long ago. He introduced what he called the cosmological constant, a term in his equations of general relativity. At the time, the prevailing view was that the universe was static, unchanging, a perfect, eternal clockwork. To achieve this, Einstein needed a force to counteract gravity's inward pull. He imagined a sort of repulsive force inherent in space itself, a constant energy density of empty space. Later, when evidence for an expanding universe emerged, he famously called this his biggest blunder. But here we are, a century later, and this very concept, this intrinsic energy of the vacuum, is now considered a leading candidate for what dark energy might be. It's as if a forgotten melody has found its way back into the symphony, a note Einstein added for stillness, that now seems to be driving the grand crescendo of expansion. So, what does this cosmic acceleration mean for the ultimate fate of our universe? If this outward push continues, or even intensifies, the future looks quite different from what we might have imagined. One possibility is the Big Freeze, or heat death. As the universe expands, galaxies will move further and further apart, eventually becoming so distant that their light will no longer reach us. Stars will burn out, black holes will evaporate, and the universe will become a cold, dark, and incredibly lonely place, a vast expanse filled with nothing but dispersed particles and fading whispers of light. Another, more dramatic scenario is the Big Rip. If dark energy's repulsive force grows stronger over time, it could eventually overcome all other forces, tearing apart galaxies, stars, planets, and even atoms themselves in a cataclysmic unraveling. It's a stark reminder that even the seemingly empty void holds immense, transformative power. Picture a balloon being inflated, but not at a steady rate. The rubber itself is stretching faster and faster, carrying the painted dots, our galaxies, away from each other with increasing urgency. If the universe is expanding and governed by these unseen forces, how did it all begin? To understand the present, we must trace the faint whispers from the universe's nascent moments, a time of unimaginable density and heat. And so we arrive at this profound juncture, where the cosmic tapestry begins to weave itself. We're talking about the universe's very first breath, its genesis. The prevailing model, the one that paints the most comprehensive picture for us, is the Big Bang Theory. Now, it's important to gently recalibrate our imagination here. This wasn't an explosion in space, like a firework bursting in the night sky. Instead, think of it as an expansion of space itself. Imagine space, the very fabric of existence, stretching, unfolding, blooming from a state of almost unimaginable density and heat. It's like a single, incredibly potent seed containing all possibilities, suddenly beginning to sprout and grow. Now, in those very first, fleeting fractions of a second, a blink of an eye so rapid, it's almost beyond comprehension, something truly remarkable happened. This period is known as the inflationary epoch. It was a moment of hyper-expansion, where the universe ballooned outwards at an astonishing rate. This wasn't just a gentle unfurling, it was a cosmic sprint. And this rapid expansion, this incredible surge, played a crucial role. It acted like a cosmic smoothing agent, ironing out any initial wrinkles or irregularities. Think of it like taking a crumpled piece of paper and stretching it perfectly flat. This smoothing is why vast stretches of the universe, even those that seem impossibly far apart, share such striking similarities in their temperature. It also, in a way, seeded the initial conditions for all the structures we see today, the galaxies, the stars, the very atoms that make up our world. Following this explosive growth spurt, the universe began to cool. And as it cooled, something else profoundly important took place, a nucleosynthesis. This happened in the first few minutes, a cosmic crucible of sorts. The universe was still incredibly hot, a searing plasma, but it was cooling just enough for the fundamental building blocks of matter to start coming together. Protons and neutrons, those tiny cosmic dancers, began to fuse, forming the nuclei of the lightest elements. Primarily, this process gave us hydrogen and helium, the most abundant elements in the universe. It's like the universe was mixing its first, essential paints, setting the elemental palette for everything that was to come. These initial proportions, these elemental fingerprints, are still imprinted on the cosmos today. But here's where it gets interesting. The Big Bang and inflation offer elegant explanations for some of the universe's most puzzling features. Take, for instance, the horizon problem. Imagine 2 points in the universe that are so far apart, light hasn't had enough time to travel between them since the Big Bang. Yet, they have remarkably similar temperatures. How could they possibly know to be the same temperature? Inflation provides an answer. These regions were once incredibly close together, sharing thermal equilibrium, before being rapidly stretched apart. Then there's the flatness problem. The universe appears to be remarkably flat, geometrically speaking. For it to be this flat after billions of years of expansion, it must have started out exquisitely flat, with an almost unbelievable precision. Inflation, again, comes to the rescue, naturally driving the universe towards this flat geometry. Imagine a single point of pure potential, containing everything that would ever be. Then, in an instant, this point began to unfurl, like a perfectly folded silk scarf expanding infinitely in all directions. But as the universe cooled and expanded, how did the fundamental forces we know begin to differentiate? And so, from that initial, shimmering, unified state, the universe began its grand unfolding, differentiating into a symphony of interactions. It's as if a single, pure note, when struck, begins to splinter into a rich chord, each note distinct yet harmoniously bound. This is how the 4 fundamental forces emerged, the silent architects shaping every interaction, from the grandest cosmic ballad to the most intimate whisper of an atom. Let's begin with gravity, the most familiar perhaps. It's the weakest, yes, a mere gentle pull, like a soft sigh across the vastness of space. But oh, its reach is infinite. It's the invisible hand that cradles planets in their orbits, the silent conductor of galaxies, holding them together in swirling luminous dances. Without gravity, the stars would scatter like dust motes in a breeze, and our very existence, this moment, this breath, would simply not be. It's the force that makes us feel grounded, tethered to this beautiful, spinning earth. Then there's electromagnetism, the vibrant artist of the everyday. This is the force behind light, the shimmering cascade of photons that paints our world in color. It's the hum of electricity, the silent pull of a magnet. Electromagnetism orchestrates the very structure of atoms. the intricate dance of electrons around their nuclei. It's the glue that holds molecules together, forming the bonds of chemistry, the essence of everything we touch, taste, and feel. It's the spark of life, the warmth of the sun, the very essence of connection. Now, let's venture into the heart of matter, into the incredibly dense core of the atom, where the truly powerful forces reside. First, the strong nuclear force. Imagine the most tenacious embrace, a bond so fierce it defies all outward push. This is the strong force, the undisputed champion of power, though its domain is astonishingly small. It's what binds quarks together, the tiny fundamental building blocks, to form protons and neutrons. And then, it holds those protons and neutrons tightly within the nucleus, a miniature universe unto itself. Without this immense, concentrated power, the very heart of matter would simply fly apart. And finally, the weak nuclear force. It's perhaps the most enigmatic, a force that whispers rather than shouts. It's responsible for certain types of radioactive decay, the slow shedding of energy from unstable atoms. But its role is far from insignificant. It's crucial in stellar processes, like the fusion reactions that power our sun, transforming hydrogen into helium, a process that ultimately gives us light and warmth. It's a subtle but essential player in the cosmic drama, a force of transformation and subtle change. It's like looking at a magnificent tapestry, isn't it? Gravity is the vast, loosely woven net that encompasses the whole grand design, holding the largest structures in place. Electromagnetism is the intricate, vibrant pattern woven throughout, creating all the beautiful details and connections we see and experience. And the nuclear forces, the strong and the weak, are the incredibly strong, tightly spun fibers at the very heart of each thread, holding the fundamental essence of the material together. Each force, with its unique strength and reach, plays its indispensable role in this magnificent cosmic creation. But if these forces are the fundamental interactions, what exactly are the building blocks they so powerfully act upon? Which of these fundamental forces do you find most fascinating, and why? At the heart of matter lies a menagerie of fundamental particles, each with its unique properties and interactions. Now, here's the beautiful part. As we peel back another layer of reality, we find that the universe isn't built from tiny, solid little marbles, but rather from a vibrant, fundamental zoo of particles. These are the true elementary building blocks, the irreducible whispers of existence. Think of them as the alphabet of the cosmos, the basic letters from which all the grand stories of matter are written. We've got these fascinating characters called quarks. There are 6 of them, like different flavors of cosmic candy. Up, down, charm, strange, top and bottom. They're a bit like shy creatures, never really found alone, always clinging to each other. And then there are the leptons. These are a bit more solitary. The most familiar is the electron, the tiny spark that dances around the nucleus of an atom, carrying the electric current that powers our world. Then there are its heavier cousins, the muon and the tau, and their even more elusive companions, the neutrinos. These neutrinos are like ghosts zipping through everything, barely interacting, like whispers in a vast, silent hall. But these quarks, they don't just wander aimlessly. They love to team up, forming what we call hadrons. The most important of these, the very bedrock of our physical selves, are the protons and neutrons. A proton, for instance, is a cozy little trio of 2 up quarks and 1 down quark, all bound together by an invisible, immensely powerful force. A neutron is similar, just swapping 1 up quark for a down, creating a slightly different, but equally crucial character. These protons and neutrons are the sturdy bricks that build the nucleus of every atom, the dense, pulsating heart of matter. And how do these particles interact? How do they communicate their influence across the vast emptiness? Through force-carrying bosons. Imagine these as little messengers, each delivering a specific kind of cosmic news. The photon, for example, is the messenger of light and electromagnetism, carrying the energy that allows us to see, that powers our very thoughts. Then there are the gluons, the incredibly strong messengers of the nuclear force, holding those quarks tightly within protons and neutrons like an unbreakable embrace. And for this weak force, responsible for radioactive decay, we have the W and the Z bosons, a bit more specialized in their interactions. And then there's the grand elusive messenger of gravity, the hypothetical graviton, a whisper we're still trying to catch in the cosmic wind. But there's one more crucial player in this particle menagerie, a truly remarkable discovery that helped us understand why things have substance. This is the Higgs boson, and it's intimately connected to the Higgs field. Imagine a vast, invisible ocean, the Higgs field. As particles move through it, some interact strongly, gaining mass like a swimmer pushing through thick water, while others glide through with little resistance. It's this interaction with the Higgs field that gives fundamental particles their mass, their inherent resistance to acceleration. Without it, electrons would zip around at the speed of light, and atoms, as we know them, simply wouldn't exist. It's like the universe has this subtle, pervasive syrup that gives things their heft, their substance. If particles have mass and interact through forces, how do they arrange themselves to create the stable structures we recognize? And so, from that almost impossibly fleeting, vibrant ballad of subatomic particles, we find ourselves witnessing something truly remarkable: the emergence of stable structures. These are the atoms, the fundamental building blocks, the very dust motes that coalesce to form all the matter we can see, touch, and even feel in the universe. Imagine, if you will, a miniature solar system, but one painted with the brushstrokes of quantum possibility. At the heart of each atom rests the nucleus, a dense, compact cluster, often described as a tiny sun. Within this core, we find protons, carrying a positive whisper of electrical charge, and neutrons, those quiet, neutral anchors. And then there are the electrons. These are not quite planets in rigid orbits, but rather, they exist in a state of constant, energetic motion, a sort of probabilistic haze, drawn to the nucleus by the gentle, insistent pull of the electromagnetic force. It's this invisible tether, this subtle attraction, that keeps the electron clouds from simply scattering into the void. Now, these electrons, they don't just wander aimlessly. They occupy specific energy levels, like distinct atmospheric layers surrounding our atomic sun. We call these regions orbitals, and they're not precise paths, but rather areas where an electron is most likely to be found. It's this quantum nature, this inherent fuzziness, that truly dictates how an atom will behave, how it will interact with its neighbors. Think of it as a unique fingerprint, a signature of energy that each electron carries. And this is where the magic of the periodic table truly unfolds. It's not just a chart, it's a map, a beautifully organized tapestry of all the known elements. Each position on this table tells a story, starting with the atomic number, the count of protons in the nucleus, the very identity of the element. But more importantly, it's the arrangement of those electrons, their configurations in those probabilistic orbitals, that truly determines an atom's chemical personality. It's like knowing how many guests are at a party, and how they're arranged in the rooms, that tells you how likely they are to mingle. This dance of electrons, particularly those in the outermost shell, the s-valence electrons, is what governs how atoms connect, how they reach out to each other. When atoms find themselves with incomplete outer shells, they're like a puzzle piece yearning for its mate. They'll share, or even transfer, these valence electrons, forming chemical bonds. It's through these bonds that atoms join hands, creating the molecules that are the very fabric of our reality, from the air we breathe to the water that quenches our thirst, and even the intricate pathways within our own bodies. So, think of atoms as these tiny, humming solar systems, with the nucleus as the radiant sun and electrons as the energetic dancers in their probabilistic clouds. Their energy levels are like distinct atmospheric layers, each with its own unique properties. If atoms are indeed the fundamental building blocks, the individual dancers, then what happens when they begin to join together, to waltz and intertwine in vast, complex arrangements? What new forms, what new expressions of reality, do they create when they form these intricate molecular dances? Before we move on to explore those grander compositions, I'm curious about your own connection to the elemental world. What is an element from the periodic table that you find particularly interesting, and why? Share your thoughts with us in the comments below. The true magic of the material world unfolds when atoms unite, weaving intricate molecular tapestries that underpin all life and structure. Take your time with this thought: the universe, in all its breathtaking complexity, is built from incredibly tiny, invisible dancers. Atoms, these fundamental building blocks, aren't content to simply exist in isolation. They yearn for connection, for a kind of atomic embrace, and this is where the exquisite art of the chemical bond begins. Imagine it like a gentle reaching out, a subtle magnetic pull. Sometimes, atoms decide to share their outer electrons, like two friends sharing a treasured secret, creating a covalent bond. Other times, one atom might generously gift an electron to another, a complete transfer that leaves them both feeling more stable, more complete, forming an ionic bond. It's all driven by a deep, inherent desire for balance, for a perfectly arranged outer shell, like fitting the last piece into a puzzle. And as these atoms link arms, they don't just form random chains. Oh no, they arrange themselves with a surprising elegance, giving rise to molecular geometry. Think of it like a delicate dance, where each atom has a specific position, a particular angle relative to its partners. This spatial arrangement isn't just about aesthetics, it profoundly dictates a molecule's personality. Does it have a slight electrical tilt, making it polar, like a tiny magnet, or is it perfectly balanced, neutral and serene? This geometry influences everything: how it behaves, how it reacts, and how it interacts with its fellow molecules, like choosing who to dance with at a cosmic ball. Consider the humble molecule of water. It's so utterly ordinary, yet it's a masterpiece of molecular design. Its bent shape, with oxygen at the apex and two hydrogens forming the base, creates a beautiful polarity. One side is slightly negative, the other slightly positive. This simple arrangement allows water molecules to form hydrogen bonds with each other, like a gentle, continuous handshake. These bonds are the secret to water's incredible properties: its ability to dissolve so many substances, its high specific heat that helps regulate our planet's temperature, and that almost magical surface tension that allows tiny insects to walk on its surface as if it were solid ground. Water, in its molecular dance, is the very lifeblood of our world, and this is where things get truly wondrous. When you gather vast numbers of these molecules together, something remarkable happens. They develop emergent properties, characteristics that belong to the collective, not to any single molecule. You can't predict the fluidity of water by looking at just one H2O molecule, nor the incredible hardness of diamond by examining a single carbon atom. It's the way they interact, the sheer force of their unified presence, that creates these new, astonishing qualities. It's like a choir: each individual voice is beautiful, but when they sing together in harmony, something entirely new and breathtaking emerges. Consider molecules like Lego bricks. While each brick has its own color and shape, it's the way they connect and form complex structures that creates functional objects, from simple chairs to intricate castles. If molecules form the basis of matter, how do they organize into the vast, dynamic systems we call life? And so from that intricate, almost unconscious dance of molecules, a truly profound transformation begins to unfold. It's the moment when the inanimate, in its own silent way, whispers the first inklings of life. This isn't a sudden spark, but rather a gradual, complex blossoming driven by the most intricate molecular interactions you can imagine. Now, how does something as extraordinary as life simply arise from what was once just non-living matter? Science offers us some truly fascinating ideas, like the primordial soup theory. Picture this early Earth, a cauldron of oceans, perhaps warmed by volcanic activity brimming with simple inorganic molecules. Over eons under the gentle, persistent energy of lightning or UV radiation, these molecules might have bumped and jiggled, slowly, patiently, forming more complex structures. Or perhaps, life's genesis was more like a hidden garden, blooming in the deep, dark, mineral-rich waters around hydrothermal vents on the ocean floor, shielded from the harsh surface. These are the whispers of abiogenesis, the idea that life's beginnings were a natural, chemical unfolding. And at the heart of many of these early theories lies a rather remarkable molecule: RNA. Think of RNA as a kind of ancient, versatile toolkit. Unlike DNA, which is primarily a blueprint, RNA can not only store genetic information, but also act as a kind of molecular matchmaker, a catalyst that helps other chemical reactions along. This is the essence of the RNA world hypothesis. It suggests that in the very dawn of life, RNA might have been the star player, handling both the instructions and the heavy lifting, before DNA and proteins took over their more specialized roles. It's like finding a single, incredibly skilled artisan who can both design and build all by themselves. But what truly sets life apart, what gives it that persistent hum of existence, is its ability to self-replicate. Imagine a simple molecule that can, in a way, make copies of itself. And then, imagine that some of these copies are ever so slightly different. This is where the magic of natural selection begins to weave its tapestry. Over unimaginable stretches of time, those molecules, or early replicating systems, that were better at making copies, or better at surviving in their environment, would simply persist. They'd leave more descendants. This slow, patient process of adaptation and diversification, driven by the fundamental urge to replicate, is the engine that powered the very first stirrings of life. And as these replicating molecules became more sophisticated, they began to enclose themselves. They built tiny, protective bubbles, and within these bubbles, they organized their internal workings. What we call a cell today is, in essence, a marvelously complex molecular machine. It's a miniature universe, a bustling city of biochemical pathways, where energy is harvested, materials are processed, and life's instructions are meticulously carried out. It's a testament to exquisite organization, a self-sustaining rhythm that allows life to not just exist, but to thrive and to pass on its legacy. It's like imagining a vast, incredibly complex orchestra. Each molecule is a single note, a specific vibration. But when these notes begin to harmonize, when they repeat in a self-sustaining rhythm, when they begin to play their own melody, that's when the symphony of life truly begins to play. And this brings us to a profound question, doesn't it? If life is fundamentally a process of molecular replication and information transmission, how does that process manage to pass its intricate instructions, its very essence, across the vast expanse of generations? What aspect of the origin of life do you find most mysterious or inspiring? At the heart of every living organism lies a coded message, a molecular blueprint that guides its development and perpetuates its form. But here's where it gets interesting. We've been exploring the grand, cosmic dance of physics, the silent hum of the universe. Yet, within each of us, there's a similarly profound, intricate dance happening at a microscopic level. It's the story written in our very essence, the blueprint of being. This extraordinary molecule, the architect of life as we know it, is called deoxyribonucleic acid, or DNA. Imagine it as a shimmering, impossibly long ladder, twisted into a gentle spiral, a double helix, like two strands of luminous pearls intertwined. This isn't just a structure, it's a library, a vast repository of instructions that dictate everything from the color of your eyes to the way your heart beats. It carries the genetic instructions for the development, the functioning, the growth, and yes, even the reproduction of all known organisms. It's the silent, ever-present script that makes you you. Now, how is this incredible story told? It's through something called the genetic code. Think of it as a universal language, a set of rules by which the information encoded in these DNA sequences is translated into the building blocks of life proteins. It's like a complex alphabet, made up of just 4 chemical letters A, T, C, and G arranged in specific sequences. These sequences are written in 3-letter words, called codons, and each codon spells out a particular amino acid, the fundamental units that link together to form proteins. It's a system so elegant, so precise, it's like a symphony composed in molecular whispers. And this symphony isn't static, it's designed for continuity, for passing on the melody of life. This is where DNA replication comes in. Before a cell divides, it meticulously copies its entire DNA library, ensuring that each new cell receives a perfect, faithful rendition of the original instructions. It's a process of duplication so precise, it's almost miraculous. And this same principle of faithful copying is how this genetic information is passed from parents to offspring, enabling inheritancy. It's how the echoes of your ancestors, their traits, their predispositions, are woven into the very fabric of your being, a legacy whispered through generations. So, what exactly do these instructions build? Specific segments of DNA, which we call genus, are like individual blueprints within that vast library. Each gene codes for a specific protein, and these proteins, they are the workhorses of the cell. They build structures, they catalyze chemical reactions, they transport molecules, they act as signals. They carry out most of the work in cells, and are absolutely required for the structure, the function, and the regulation of your body's tissues and organs. It's the genes, through the proteins they command, that orchestrate the entire orchestra of your existence. Think of DNA as an ancient library, filled with intricate blueprints. Each gene is a specific blueprint for a particular component, a window frame, a support beam, a tiny cog in a grand machine. And the entire library, this magnificent collection of building plans, is meticulously copied and passed down through generations, ensuring that the blueprint for life itself is never lost, always evolving, always continuing. If DNA is the blueprint, how does the organism interpret and act upon these instructions? The silent language of DNA must be translated into the active machinery of life, a process of exquisite molecular communication. And so, we arrive at this fascinating juncture, where the blueprint, the very essence of life's code, is not merely a static set of instructions, but a vibrant, dynamic whisper that must be heard and acted upon. Think of it as a grand, ancient library, holding within its hushed halls the secrets to every leaf, every feather, every beating heart. But how does this wisdom, this silent symphony of nucleotides, actually become the rustle of leaves or the beating of wings? It's a journey of translation, a delicate dance of molecules, and it all begins with transcription. Imagine a single, precious scroll unfurling from the vast DNA helix. This scroll isn't the original, mind you. It's a faithful, yet temporary copy, a messenger carrying a specific segment of the genetic message. This messenger molecule, called messenger RNA or mRNA, is like a whispered secret, carefully transcribed from the master text. It's a fleeting echo, designed to carry its vital information out of the nucleus, the central archive, and into the bustling workshops of the cell, where the real magic of creation begins. This mRNA, this delicate whisper, then embarks on its next grand adventure or translation. It finds its way to these incredible molecular machines called ribosomes, the cell's tiny, tireless factories. Here, the language of nucleotides, those 4 letters of the genetic alphabet, is finally read and understood in a completely new tongue, the language of amino acids. Think of transfer RNA, or tRNA, as the skilled translators, each carrying a specific amino acid like a tiny, perfectly formed building block. They read the mRNA sequence, 3 letters at a time, like a code, and bring the correct amino acid to the ribosome. And as they arrive, one by one, they link together, forming a long, shimmering chain. This chain, this nascent protein, is the direct result of that initial DNA whisper, now given form and substance. It's a testament to the intricate choreography happening within us, a constant construction of the very fabric of our being. But a protein isn't just a string of beads. Oh no, that linear chain is merely the potential. To become functional, to do its job, whether it's to carry oxygen, build muscle, or fight off an invader, it must undergo a profound transformation, a protein folding. This is where the magic truly deepens. The amino acid chain, guided by subtle forces and its own inherent chemical nature, begins to twist and turn, to coil and pleat, spontaneously arranging itself into a precise, 3-dimensional shape. It's like a delicate origami, where every crease and fold is crucial for its purpose. This intricate, sculpted form is what gives the protein its unique identity and its ability to interact with other molecules, to perform its designated task within the cellular orchestra. Without this precise folding, the protein is just a jumbled mess, a potential unfulfilled. And all of this incredible molecular ballot, this transcription, translation, and folding, doesn't happen haphazardly. It's all under the watchful eye of gene regulation. Imagine a vast, complex city, where different neighborhoods have different needs at different times. Gene regulation is like the city's traffic control, its zoning laws, its carefully orchestrated symphony of activity. It ensures that specific genes are turned on or off, that proteins are produced only when and where they are needed, and in the precise quantities required. This exquisite control allows for cellular specialization, for a nerve cell to be a nerve cell, and a muscle cell to be a muscle cell. It's how our bodies respond to the world around us, adapting and evolving with every breath. It's really quite beautiful, isn't it? Imagine a chef receiving a recipe, written in a secret ink on a scroll of ancient parchment. That's our DNA. They can't take the original scroll into the heat of the kitchen, so they carefully write down the recipe on a special, heat-resistant notepad. That's the mRNA. Then, using that notepad, they gather their ingredients, their amino acids, and with the precise instructions, they assemble a magnificent dish, a protein, perfectly crafted for its purpose. If life is a complex system of interacting molecules, what governs the intricate coordination of these interactions? From the fundamental building blocks of matter to the intricate machinery of life, we now turn towards the most profound emergent property, consciousness. Now, here's the beautiful part. Think of the brain not as a single, monolithic entity, but as an unimaginably vast, intricate network. Billions upon billions of neurons like tiny, luminous stars, all connected, all humming with electrochemical whispers. Consciousness, in this view, isn't located in one specific spot. It emerges from the ceaseless, complex dance of these signals, a symphony played out across the celestial landscape within us. It's like the scent of rain on dry earth. It's not the water, not the soil, but the beautiful interaction between them. Scientists are diligently searching for what they call the neural correlates of consciousness, or NCC. Imagine trying to find the exact spark that ignites a fire, or the precise note that makes a melody truly sing. They're looking for the minimal neural activity, the barest minimum of brain states, that are jointly sufficient for us to have a specific conscious experience. It's about understanding which patterns of brain activity correspond to the feeling of warmth, the taste of honey, or the echo of a forgotten memory. It's a quest to map the physical terrain of our inner world. Then there's the fascinating information integration theory, or EAT. This theory suggests that consciousness arises from a system's capacity to integrate information. The more complex and interconnected the information within a system, the higher its level of consciousness. Think of it like a vast library. A single book holds information, but the true richness comes from how all the books relate to each other, how ideas weave together across countless volumes. A system that can integrate more information, that has a deeper web of connections, is thought to possess a more sophisticated form of consciousness. But this brings us to the deep, shimmering waters of the hard problem of consciousness. We can describe the electrochemical signals, we can map the neural pathways, but why and how do these physical processes give rise to subjective experience? Why does a particular pattern of firing neurons feel like the redness of a rose, or the melancholy of a cello note? These are what we call qualia, the raw, subjective feel of experience. They're the colors we see, the sounds we hear, the emotions we feel, the very essence of being alive, and the most profound mystery of all. Imagine a vast symphony orchestra. While each instrument plays its part, the true richness and emotion of the music emerge from the unified, harmonious interplay of all the instruments, a phenomenon greater than the sum of its parts. If consciousness is an emergent property, how might it interact with the physical world, or even influence it? The intricate dance between the physical brain and the subjective experience of consciousness, well, it raises some truly profound questions, doesn't it? It's like trying to understand a melody by only looking at the sheet music, or perhaps by only feeling the vibrations of the instrument. They're undeniably linked, but how precisely? We've all felt it, haven't we? That subtle shift when a heavy worry settles in, and suddenly your shoulders feel like they're carrying stones, or your stomach twists into a tight knot. This is the realm of the psychosomatic effects, where our inner world, our thoughts and emotions, can paint vivid pictures on the canvas of our physical health. Think about the gentle hum of anxiety that can disrupt sleep, or the quiet joy that seems to make the world brighter, even physically lighter. Stress, for instance, can whisper to our immune system, dimming its vibrant colors, making us more susceptible to the subtle invasions of illness. It's a powerful testament to the fact that our mind isn't just an observer of our body, it's an active participant, a co-creator of our physical reality. And then there are those fascinating phenomena, the placebo and nocebo effects. Imagine believing so deeply that a sugar pill is a powerful medicine, that your body actually responds, releasing its own natural painkillers or anti-inflammatories. It's as if the intention itself, the pure mental conviction, can conjure tangible physiological changes. Conversely, the nocebo effect shows us the shadow side, where a negative expectation can manifest as real discomfort or illness. It's a gentle reminder of the immense power held within our beliefs, a power that can sculpt our physical experience from the inside out. It's like planting a seed of expectation in the fertile soil of our physiology and watching it bloom, for better or for worse. This brings us to the truly astonishing concept of neuroplasticity. Our brains aren't static statues carved in stone from birth. Instead, they are more like living gardens, constantly being reshaped by the sunlight of our experiences and the gentle rain of our thoughts. Every time we learn something new, every time we practice a skill, or even just revisit a cherished memory, we're literally forging new neural pathways, strengthening existing ones, and pruning away the unused connections. Our thoughts, our intentions, our very focus, can physically alter the intricate architecture of our brain. It's a continuous, beautiful process of self-creation, a testament to the mind's ability to sculpt its own physical home. Now, venturing into more speculative, yet utterly intriguing, territories. Some theories suggest that even the most fundamental aspects of consciousness might be intertwined with the very strange dance of quantum mechanics. Imagine the possibility that the deep, inner workings of our minds, the very spark of awareness, might be playing out on the quantum stage. Ideas like quantum coherence within the microtubules of our brain cells, as proposed in theories like OR, hint at a universe where the observer and the observed, the mind and the matter, are not so separate after all. While these are still frontiers of exploration, they offer a glimpse into a reality far more interconnected than we might initially perceive. Think of it this way: the mind is like the captain of a magnificent ship, our body. The captain's decisions, their mood, their focus, their unwavering belief in reaching a destination, all of this profoundly influences the ship's journey. The captain's calm hand on the tiller can navigate through storms, their vigilance can prevent unseen hazards, and their very presence can inspire the crew to work with seamless efficiency. The ship's speed, its course, even its structural integrity, can be shaped by the captain's inner state. And if our thoughts can influence our bodies, if they can influence the very structure of our brains, it leads us to a truly breathtaking question, doesn't it? Can our minds, our consciousness, influence the very fabric of reality that exists or beyond our personal physiology? That's a journey we'll gently begin to explore next. Returning to the quantum realm, we revisit a concept that hints at the active role of the observer in shaping reality itself. Take your time with this thought, it's a deep one, like peering into a well where the bottom seems to shift with your gaze. We've touched upon the was measurement problem before, haven't we? That peculiar moment in quantum mechanics where a system, existing in a delicate haze of possibilities, a superposition, we call it, suddenly snaps into a single, definite state the very instant we try to measure it. It's as if the universe holds its breath, waiting for our attention before it decides which path to take. This isn't like dropping a stone into a pond and watching the ripples. It's more like the pond itself, choosing its shape based on whether you're looking. The act of observation, it seems, isn't a passive glance, but an active participation. And this is where the waters get wonderfully murky, philosophically speaking. You have interpretations like the Copenhagen interpretation, which suggests that consciousness itself might be the catalyst, the spark that collapses that wave of potential into the solid form of reality we perceive. Then there are other perspectives, like the many worlds interpretation, which proposes that instead of collapsing, the universe simply branches. Every possibility plays out in its own separate, unfolding reality. Neither interpretation denies the profound influence of observation, but they offer vastly different landscapes for what that influence means. It's like standing at a crossroads. Do you choose one path and leave the others behind, or does every choice sprout a new, parallel journey? Then there's this fascinating phenomenon called the quantum Zeno effect. It's a bit like trying to keep a shy creature still by constantly watching it. If you observe a quantum system frequently enough, with enough repeated measurements, you can actually prevent from naturally evolving or changing its state. You can, in a sense, freeze it in time, holding it in whatever state you last observed. Imagine a delicate dewdrop on a spider web, shimmering with all the colors of the dawn. If you keep your eye fixed on it, so intently that you never blink, you might find that dewdrop lingers, resisting the inevitable evaporation that the sun's warmth would normally bring. The observer's focused attention, their persistent gaze, can indeed alter the very unfolding of existence at its most fundamental level. This naturally leads us to ponder the role of consciousness. Is consciousness the sine qua non, the absolute prerequisite for this quantum dance of collapse? Or is measurement simply a broader term for any interaction that decoheres the system, that breaks that delicate quantum superposition through its entanglement with the larger environment, whether that environment is a sophisticated detector or, perhaps, a conscious mind? It's a question that hums with the possibility that our very awareness is woven into the fabric of what is real, not just a passive witness to it. Imagine a dream that shifts and solidifies only when you try to grasp its details. The act of focusing your attention brings a fleeting aspect of the dream into a more defined form, like trying to catch mist in your hands. If observation can influence the quantum world, could collective consciousness or intention have broader cosmic implications? As we delve deeper, we encounter one of reality's most persistent enigmas, the elusive nature of time itself. It's such a peculiar thing, isn't it? We live our lives as if time is this steady, relentless march forward, a river carrying us along. But when we look closer, when we really try to grasp it, it begins to shimmer and shift. Think about how we talk about space-time, that interwoven fabric of existence. In that grand tapestry, time isn't just some fleeting moment, it's treated as a dimension, much like length, width, and height. The only wrinkle, of course, is that we seem to experience it only in one direction, a one-way street. This leads to some fascinating ideas, like the concept of a block universe, where every moment, every sunrise, every whispered word, every future possibility already exists, laid out like a vast, timeless scroll. It's as if the entire movie of existence is already filmed, and we're just watching it unfold, one frame at a time. And why this seemingly unidirectional flow? Well, science points us towards the arrow of time, and a big part of that is linked to something called entropy. Imagine a perfectly ordered deck of cards, all sorted by suit and number. Now shuffle them. It's incredibly easy to go from order to disorder, isn't it? But try to unshuffle them back into that perfect order, just by random shuffling. It's practically impossible. The universe is a bit like that deck of cards. It tends to move from states of low entropy, or order, to states of high entropy, or disorder. This increase in disorder is what gives time its direction. It's why we have memories of the past, but not of the future. The past is the state of lower entropy, the more ordered state, and the future is the state of higher entropy, the more disordered state. It's like a cosmic sigh, always moving towards a more relaxed, less structured arrangement. Then there's Einstein, of course, who showed us that time isn't this rigid, absolute ruler we might have imagined. Through his theories of relativity, we learned that time itself can stretch and bend. Think about time dilation. The faster you move, the slower time passes for you compared to someone standing still. And gravity, too, has its way of warping time. Near massive objects, like black holes, time slows down. It's not a universal clock ticking at the same rate for everyone. It's a deeply personal, relative experience, influenced by the very fabric of the universe around you. It's like each of us is on our own slightly different time stream, subtly out of sync with everyone else. And if we dive even deeper into the strange, fuzzy realm of quantum mechanics, the picture of time becomes even more enigmatic. At the most fundamental level, at the incredibly tiny scale of the Planck length, time might not even behave like a continuous flow. Some theories suggest it might be quantized, broken into tiny, discrete packets. It's as if the very concept of now dissolves into a probabilistic haze, and the arrow of time, so clear in our everyday lives, becomes something far more subtle, perhaps even an emergent property of the universe, rather than a fundamental constant. It's like trying to understand the smooth flow of water by looking at individual water molecules. The collective behavior is clear, but the individual components are a different story altogether. Imagine a river flowing. We perceive a distinct no as the water moves past us, a fleeting glimpse of the present. But the river itself, the entire flow from its source, winding through valleys, gathering tributaries, all the way to the sea, the river exists simultaneously. It's a continuous, unbroken entity, and our experience of now is just our perspective as we float along its surface. If time is so complex, so fluid, What does this imply about our perception of reality, about memory, and about the very idea of cause and effect? How do you personally experience the passage of time? Does it feel constant, or does it change for you? Our experience of time is intrinsically linked to our understanding of cause and effect, shaping our perception of reality. Now, here's the beautiful part: our journey into the very fabric of existence often leads us to ponder this fundamental dance of causality. It's this deep-seated principle that tells us, with a gentle certainty, that events don't just happen in a vacuum. They have roots, they have origins. Think of it like a delicate chain, each link forged by the one before it. A cause, then an effect, unfolding in a sequence that feels as natural as the tide meeting the shore. This predictable rhythm is what allows us to make sense of the world, to build our understanding, to navigate the currents of life. It's the bedrock upon which we construct our reality, a silent promise that actions have consequences, that the ripple we create will eventually return. But here's where things get truly fascinating, where the smooth surface of causality begins to shimmer with a different kind of light. Our perception of this cause and effect ballet isn't quite as objective as we might imagine. It's more like a painting, meticulously crafted by our own brains. Our past experiences, the whispers of memory, the focus of our attention, even the subtle biases that color our thoughts, they all play a role in how we see the connection between events. What appears to be a direct cause, a clear line drawn from A to B, might, in reality, be a subtle correlation, a beautiful coincidence that our minds weave into a narrative of inevitability. It's like looking at a tapestry. You see the pattern, the flow, but the individual threads, though connected, have their own distinct existence. And then, we touch upon the edges of the quantum realm, where the familiar rules of cause and effect begin to blur, like mist on a morning window. Here, some rather mind-bending ideas emerge, like a retrocausality. Imagine, if you will, the effect somehow nudging its cause, a future whisper influencing a past echo. It's a concept that challenges our deeply ingrained sense of linear progression, suggesting that perhaps time itself isn't the rigid, one-way street we often perceive. It's as if the universe, in its infinite wisdom, is playing with our understanding, showing us that the story of existence might be far more intricate, far more interconnected, than our everyday senses can fully grasp. Our grasp of causality is also inextricably bound to the twin powers of memory and thus future projection. Memory, that soft archive of past events, allows us to recall the causes that led us to this very moment. And then, with the same mental muscle, we project ourselves forward, imagining the potential outcomes, the future effects that our current actions might ripple into being. It's this constant interplay between looking back and looking ahead, guided by our understanding of what makes things happen, that shapes our choices, our hopes, and our very sense of agency in the world. Imagine watching a film. We see events unfold sequentially, frame by frame, assuming the preceding frame caused the next. But all those frames, in their entirety, exist simultaneously on the film reel, a complete story waiting to be unspooled. It challenges our linear perception of cause and effect, doesn't it? It hints that perhaps our experience of time, and the causality we perceive within it, is just one way of viewing a much larger, more interconnected reality. If our perception is so subjective, so beautifully constructed, what then is the true nature of objective reality, existing beyond the unique lens of our individual minds? As we weave together these threads of physics, biology, and consciousness, we are led to ponder the very essence of what is real. It's a question that tickles the edges of our understanding, isn't it? We often talk about subjective reality, this idea of a world out there, existing quite independently of whether we're here to witness it. Like a mountain, solid and unwavering, even when no eyes gaze upon its peak. But then, there's our subjective reality. This is the world as it unfolds within us, painted with the hues of our perceptions, our memories, our feelings. It's the warmth of the sun on your skin, the melody of a forgotten song, the silent ache of longing. And the fascinating, sometimes dizzying, challenge is trying to bridge that gap, to understand how our inner world, so fluid and personal, connects with that supposed outer world, so seemingly fixed and universal. It's like trying to catch moonlight in a sea beautiful, but elusive. And then, the mind wanders to even more profound depths. What if this whole vibrant, tangible existence we experience, the laughter of children, the scent of rain on dry earth, the vast, star-dusted canvas of the night sky, what if it's all a kind of simulation? A grand, incredibly detailed program, running on some cosmic computer? So sophisticated that we can't even perceive the edges of its code. It's a thought that can feel both unsettling and strangely liberating, can't it? If it's a simulation, then what does real, truly mean? Is a simulated sunset any less beautiful? Is a simulated love any less potent in the moment? It forces us to question the very foundations of our being, to ask if we're actors on a stage, or perhaps, the dreamers of the dream. This leads us to a different way of looking at things, a perspective that whispers that perhaps consciousness itself is the fundamental building block of everything. Imagine, if you will, that the material world, the atoms and molecules, the galaxies spinning in the void are not the primary players, but rather they arise from consciousness. Like ripples on a vast, calm lake, the world of form and matter emerges from the boundless ocean of awareness. In this view, our individual consciousness isn't just a passenger in a physical body, but a unique expression of that primary consciousness, a focal point through which the universe experiences itself. It's a subtle shift, but one that can reframe our entire relationship with existence. And when we consider these various facets, a beautiful picture begins to emerge, one of holism and interconnectedness. It's the idea that nothing truly exists in isolation. Every particle, every star, every living being is part of an immense, intricate web. We can zoom in, of course, and marvel at the exquisite detail of a single dewdrop, or the complex dance of subatomic particles. But to truly understand its nature, we must see it within the context of the entire ecosystem, the entire universe. The universe in this sense isn't a collection of separate things but a single, unified, pulsating whole. Imagine a vast, intricate tapestry. We can examine individual threads, perhaps a shimmering silk or a rough-spun wool, or we can marvel at the patterns woven into its fabric, a soaring eagle, a blooming rose, a distant mountain range. But the true essence, the breathtaking artistry, lies not just in the threads or the patterns, but in the interconnected whole. Each thread, each knot, each color choice contributes to the overall design, the grand narrative of the tapestry. And we, too, are threads within this cosmic weave, inseparable from the masterpiece it creates. If reality is so profoundly interconnected, what are the principles that govern this cosmic harmony, this grand, interwoven dance of existence? What does real mean to you? Share a thought or feeling about the nature of reality. As we perceive the universe as an interconnected whole, we begin to sense underlying principles of harmony and resonance. But here's where it gets interesting. It feels as though the very fabric of existence, the grand tapestry of reality, is woven with threads of cosmic harmony and resonance. Think about the fundamental constants, those bedrock numbers that govern everything. The gravitational constant, the speed of light, Planck's constant, they seem almost delicately tuned, don't they? Like the precise settings on an ancient, cosmic instrument, perfectly calibrated to allow for the emergence of complexity, for the unfurling of stars, galaxies, and eventually, life itself. If these numbers were even slightly different, our universe might be a barren, silent expanse, devoid of the vibrant symphony we experience. It's as if the universe whispered its secrets into existence, and these constants are the very words of that whisper. And then there's this fascinating idea, championed by thinkers like Max Tegmark, that the universe is, at its deepest level, fundamentally mathematical. Imagine the cosmos not as a collection of random events, but as a grand, unfolding equation, a breathtakingly intricate theorem. Its structure, its laws, its very existence, all arising from the pure, abstract beauty of mathematics. It suggests an inherent order, a deep-seated harmony that resonates through every atom, every star, every thought. It's like discovering that the most beautiful music is not just heard, but is also the underlying structure of the concert hall itself. This idea of resonance isn't just confined to abstract concepts, it's everywhere in nature. From the subtle vibrations of atoms, humming their specific frequencies, to the grand, balletic dance of planets in their orbits, locked in orbital resonances, a cosmic rhythm. It's as if the universe is a vast orchestra, and everything, from the smallest particle to the largest celestial body, is playing its part, contributing to an overarching, interconnected melody. We see it in the way a tuning fork can make another, identical tuning fork vibrate, even without touching. It's a testament to the universe's inherent inclination towards sympathetic connection. This brings us to the more philosophical notion of sympathetic vibrations. It's this idea that like frequencies, when present, can influence each other, can resonate together, even across vast distances. It hints at a deeper, perhaps non-local connectedness, a silent conversation happening between all things that share similar vibrational patterns. It's like a whisper across the void, a recognition of shared essence. Imagine a vast choir where every singer is attuned to a specific pitch. When the right combination of voices sings, a beautiful, resonant chord is produced, filling the space with harmonious energy. If the universe operates on principles of resonance, what does this suggest about the potential for influence and transformation? At the root of all physical phenomena lies energy, a fundamental currency that flows and transforms, shaping all existence. And as we delve deeper into the quiet hum of reality, we arrive at a concept so profound, so utterly foundational, it's like the very breath of the universe, the energy of existency. Imagine, if you will, the universe as a vast, intricate tapestry, and energy is the thread that weaves it all together. It's not something you can hold in your hand, not something you can see with your eyes, yet it's the engine behind every sunrise, every whisper of wind, every beat of your own heart. At its most fundamental level, physics tells us something truly remarkable through the first law of thermodynamics. Energy cannot be created or destroyed, only transformed. Think about that for a moment. It's like the universe has a cosmic savings account, and the total amount in that account never changes. It can be moved around, exchanged, converted into different forms, but the grand total remains. This principle, this conservation of energy, is the bedrock upon which so much of our understanding of the physical world is built. It's why perpetual motion machines, those delightful flights of fancy, are ultimately just that, fantasies. The energy simply has to come from somewhere, and it has to go somewhere. And what glorious forms this energy takes! We experience it in so many ways, each with its own unique character. There's kinetic energy, the energy of motion, like the swift flight of a bird or the gentle ripple of water. Then there's potential energy, the stored energy waiting to be released, like a coiled spring or a boulder perched precariously on a cliff edge. We feel thermal energy as warmth, the subtle vibration of atoms dancing within matter, a cozy blanket on a cold night. Electromagnetic energy paints our world with light and color, carrying information across vast distances, the silent language of the cosmos. Chemical energy is locked within the bonds of molecules, fueling the processes of life, the very essence of sustenance. And then there's the immense power of nuclear energy, held within the heart of atoms, a force both beautiful and terrifying. These forms are not static, they dance and interconvert constantly. A falling apple transforms potential energy into kinetic energy. The sun's rays, a form of electromagnetic energy, are captured by plants and converted into chemical energy through photosynthesis. It's a perpetual, elegant ballad of transformation. But what if there's even more? What if the universe holds a deeper reservoir of energy, a latent potential even in the seemingly empty void? This is where we touch upon the fascinating concept of zero-point energy. In the strange and wonderful realm of quantum mechanics, even at absolute zero temperature, where all classical motion is thought to cease, there's still a residual energy. It's like a subtle, underlying vibration of existence itself, present in the vacuum, a kind of cosmic hum. It suggests that even the deepest stillness is alive with a subtle, inherent energy. It's a concept that hints at a universe far more alive and vibrant than we might initially perceive. And this leads us to a question that gently nudges the boundaries of our understanding: the relationship between energy and consciousness. Is consciousness simply a byproduct of complex physical energy, or could it be something more? Could consciousness itself be a form of energy, perhaps an informational field that interacts with or is even influenced by the physical energies that surround us? Imagine consciousness not as a passive observer, but as an active participant, a subtle frequency that resonates with the energetic symphony of the universe. It's a philosophical exploration, a gentle unfolding of possibilities, a whisper of connection between the tangible and the intangible. Think of energy as the universal currency. It can appear as cash, like the kinetic energy of a running child, or stored in a bank, like the potential energy of a dammed river. It's exchanged through transactions, these constant transformations, but the total amount in the system, the grand cosmic balance, remains remarkably constant. If energy is so fundamental and so conserved, what does this imply about our own potential for transformation, for personal influence within this grand energetic flow? What is one small act of energy transformation you observe today? Beyond discrete particles and forces, physics describes reality in terms of pervasive fields, potentials that shape the universe. Take your time with this thought. In the grand tapestry of existence, what we perceive as solid, tangible things, the very particles that make up everything around us, are, in a way, just ripples on a much deeper, more fundamental pond. In the realm of quantum field theory, the universe isn't so much a collection of tiny billiard balls, but rather a symphony of underlying fields. Imagine these fields as something like an invisible, all-pervading ether, but far more dynamic and intricate. The electromagnetic field, for instance, is everywhere, and what we experience as light or electricity are simply its localized excitations, like a shimmer on the surface of a vast, unseen ocean. Then there's the Higgs field, which, as we've touched upon, imbues particles with their mass. Each fundamental particle we know of, the electron, the quark, the photon, is understood not as an independent entity, but as a vibration of quiver within its corresponding field. These fields aren't confined to specific locations, they permeate all of space-time, from the deepest void between galaxies to the very core of your being. And what of this so-called empty space, the vacuum? It turns out, it's anything but empty. It's a bustling, vibrant place, a veritable sea of potential energy. The quantum vacuum is teeming with activity, a constant dance of virtual particles that wink into existence and then vanish just as quickly, like fleeting thoughts in a cosmic mind. They borrow energy from the vacuum for an infinitesimal moment, only to return it, leaving behind a subtle imprint, a sort of energetic memory. This constant flux, this effervescent bubbling, means that the vacuum itself is a fundamental aspect of reality, a dynamic medium from which all manifest particles can arise. It's like a perfectly still lake, where the water itself is the field, and the occasional, ephemeral ripples are the virtual particles, a testament to the slower, underlying energy. And in this intricate dance of fields and virtual particles, an intriguing idea emerges that information might be as fundamental as energy and matter. These fields, these pervasive potentials, can be seen as the very carriers of information. They hold the blueprints, the possibilities, for what can manifest. Think of it like a musical score. The notes themselves are the actualized sounds, but the score, the written arrangement, is the potential for those sounds, the information that guides their creation. The fields are the cosmic score, holding within them the latent possibilities of all that can be, waiting for the right conditions to be played out, to be heard. This brings us to a beautiful resonance with ancient wisdom, particularly with Aristotle's concept of potentiality and actuality. He spoke of how things exist not just as they are, but also as they could be. An acorn holds the potential to become a mighty oak, a sculptor's block of marble holds the potential for a statue. In this quantum context, the fields are the ultimate realm of potentiality. They are the latent possibilities, the unmanifested forms that exist before any specific interaction or observation solidifies them into actuality. It's as if the universe holds an infinite library of possibilities, and these fields are the pages, waiting to be read, waiting to be brought into being. Imagine a vast, silent lake. The water itself, stretching out, deep and unbroken, is the field, and the ripples or waves that occasionally dance across its surface, those are the particles, the temporary, fleeting manifestations of the underlying, continuous medium. The lake is always there, always the same water, but the waves come and go. So, if reality is truly built on these pervasive fields of potential, these silent lakes of possibility, then a fascinating question arises. What role does our own intention, our focused awareness, play in actualizing these potentials? From the subtle dance of quantum fields, we explore the intriguing concept of how focused intention might influence the unfolding of reality. Now, here's the beautiful part. We've touched upon the observer effect before, that curious notion that simply by looking, by observing a quantum system, we can nudge it from a fuzzy cloud of possibilities into a single, defined state. Imagine a shy butterfly, fluttering between 1,000 different flowers, its path utterly undecided. But the moment you focus your gaze, your avge intention to see which flower it lands on, it's as if the very act of your attention guides its wings, and it settles decisively on one. This isn't just a quaint idea from physics, it hints at a deeper connection between our inner world and the outer fabric of existence. And this connection, this subtle interplay, has been the subject of fascinating, albeit sometimes controversial, research. Think of studies like those by Dean Radin and others that have explored whether human intention can actually influence random number generators. These are machines designed to produce truly random sequences, like a cosmic coin flip. Yet, some experiments suggest that when people focus their intent, a clear, directed desire for the machine to produce more heads or more tails, the output subtly shifts, deviating from pure chance. It's like whispering a suggestion to the universe and finding, to your surprise, that it might just listen. Of course, these findings are debated, and the scientific community is always seeking more rigorous ways to understand these delicate influences. But the questions they raise are profound. Beyond these direct experiments, there's the undeniable power of our beliefs. Our beliefs are like the deep roots of a tree, anchoring our perception and shaping our actions in ways we might not even consciously realize. If you deeply believe you are capable of achieving something, that belief will subtly alter your posture, your approach to challenges, the very opportunities you notice. It's not magic, but a beautiful dance of psychology, and perhaps something more. This can manifest in what we call psychosomatic effects, where our inner state influences our physical well-being, or simply through the way our conviction opens doors that might have remained closed to doubt. Our beliefs, in essence, paint the world we see. Philosophically, this idea of intention influencing reality resonates with ancient wisdom and modern thought alike. Many traditions suggest that consciousness isn't just a passive byproduct of matter, like the scent of a flower that fades when the petals dry. Instead, they propose that consciousness is an active participant, a co-creator. Imagine the universe as a vast, unwritten symphony. We, with our intentions, our desires, our focused awareness, are like the conductors, guiding the notes, shaping the melody, and bringing forth a particular arrangement from an infinite potential score. It's the idea that we're not just passengers on a journey, but perhaps, in a very real sense, we're helping to chart the course. Think of a sculptor working with clay. The clay holds infinite potential shapes, a smooth, unformed mass with the capacity for anything. But it is the sculptor's focused intention, their clear vision for the final form, the curve of a cheek, the drape of fabric, that guides the hands, that shapes the material, and brings a specific, beautiful sculpture into being. Our intentions are like that sculptor's vision, guiding the raw potential of existence. If intention can influence potential, how can we cultivate a more harmonious and beneficial relationship with the universe? Understanding the subtle interplay between consciousness and the cosmos invites us to cultivate our own inner state of resonance. But here's where it gets interesting. As we journey through these vast landscapes of cosmic thought, we often find ourselves returning to a most intimate and profound space, our own inner world. Cultivating inner resonance isn't about grand gestures or external achievements. It's about the quiet, persistent art of tending to the garden of our being. It's about learning to listen to the hum of our own existence, to find that sweet spot where our personal frequency aligns with the grand symphony of the universe. So, how do we begin to weave this tapestry of inner harmony? It starts with a gentle anchoring in the present moment. Mindfulness, at its heart, is simply the practice of non-judgmental awareness. It's like becoming a keen observer of your own inner weather, noticing the clouds of thought, the breezes of emotion, without needing to change them, just to see them. This grounding in the here and now, this precious, fleeting instant, is our only true point of interaction with reality. It's where the universe whispers its secrets directly to us, if only we're quiet enough to hear. Imagine the feeling of cool grass beneath your bare feet, the warmth of the sun on your skin, the scent of damp earth after a rain. These are not just sensations, they are invitations to be here, fully and completely. And as we anchor ourselves in the present, we can also begin to cultivate a sense of emotional harmony. Think of your emotions as colors in a painter's palette. While all colors have their place, there's a particular radiance that emerges when we intentionally mix hues of gratitude, compassion, and joy. These aren't just fleeting feelings, they are powerful energetic states that can profoundly influence how we perceive the world and how the world, in turn, perceives us. When our inner landscape is painted with these vibrant, positive colors, our interactions become softer, our perceptions clearer, and a subtle, beautiful coherence begins to weave itself into the fabric of our days. It's like carrying a small internal sun, warming everything it touches. Beyond our immediate emotional state, there's also the profound practice of aligning with universal principles. These are the subtle currents that flow through all of existence: balance, interconnectedness, non-harming. When we strive to live in harmony with these principles, when we seek balance in our own lives, recognize our deep connection to all beings, and choose paths that cause no unnecessary harm, something magical happens. We begin to feel a sense of inner alignment, a quiet knowing that we are not adrift, but rather a vital, contributing note in the grand, cosmic melody. It's like finding the natural flow of a river, moving with effortless grace rather than against the current. And to truly hear this cosmic melody, we must embrace the power of stillness. In our busy, buzzing world, stillness can feel like a foreign concept, almost a luxury. But it's in these moments of quiet contemplation, these pockets of deep silence, that the most profound insights often emerge. It's like allowing a muddy pond to settle. Gradually, the murkiness clears, and the hidden treasures at the bottom become visible. Stillness allows us to connect with the subtle energies and information that are constantly flowing within and around us, often drowned out by the noise of our everyday lives. It's in the quiet spaces that we can truly feel the pulse of the universe and our own place within it. Imagine tuning a musical instrument. By carefully adjusting each string, ensuring it sings with the correct pitch, the instrument is then ready to produce beautiful, harmonious melodies. Similarly, by cultivating inner balance, by tuning our own inner strings of presence, emotion, and alignment, we too can resonate more harmoniously with the grand orchestra of the universe. As we absorb these profound concepts, how do we carry this sense of wonder and interconnectedness forward? And so, we've journeyed together, from the tiniest quantum whisper, the almost imperceptible hum of existence at its most fundamental, all the way out to the vast, silent expanse of the cosmos. We've traced the intricate, almost balletic dance of particles, how they weave and unweave themselves, and we've felt the subtle pull of space-time bending, like a silken cloth draped over unseen forms. We've marveled at the universe's grand outward breath, its ceaseless expansion, and then, with a sense of profound awe, we've watched life emerge, and from that fertile ground, consciousness itself, like a delicate bloom unfurling in the cosmic dawn, we touched upon the invisible threads of fundamental forces, the tiny, resilient building blocks of all that is, the elegant blueprint etched into DNA, and the deep, resonant mystery of our own awareness. We even considered how subtle energies, unseen fields, might be the very warp and weft of reality's tapestry, and how, in turn, our own inner state, our own quiet resonance, can harmonize with this grand, universal symphony. The slow, deliberate turning of timeless physics, it seems, reveals a universe that is both profoundly ordered, like a celestial clockwork ticking with unimaginable precision, and yet beautifully mysterious, holding secrets in its depths that we're only just beginning to glimpse. It suggests a deep, intrinsic interconnectedness, a web of being that stretches from the infinitesimally small, the subatomic dust motes, all the way out to the grandest nebulae, and perhaps even deeper, into the very core of our own selves. As we continue to explore, let's try to hold on to that precious sense of wonder, that unquenchable curiosity, and that gentle understanding that we are not just separate observers, peering in from the outside. No, we are integral parts of this unfolding, magnificent cosmic narrative. The universe isn't just out there, a distant spectacle, it's also within us, a living, breathing reflection of its own infinite, boundless potential. And now your thoughts, your own unique reflections, are such a vital part of this shared exploration. Please, if something resonated particularly deeply with you today, or if a new question has gently surfaced in the quiet spaces, do share it in the comments below. Your presence, your participation, it creates such a beautiful, warm resonance within our little community here. Thank you truly for sharing this journey with me. And now, as this exploration gently concludes, allow the quiet, steady hum of those universal laws, those timeless principles, to lull you into a state of deep, encompassing peace. Let your breath deepen, just a little more. Allow your body to relax, to soften, and let your mind drift, like a leaf on a gentle stream, into a restful sleep, carrying the soft echoes of this timeless physics, these cosmic whispers into your dreams. May you find profound, restorative rest tonight. Good night.